Hi there, and welcome to a Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this lesson we are going to begin our next chapter, chapter number 4, on systems of equations and inequalities. Now in this chapter we're going to be looking at systems of equations and inequalities. Now that word I just said twice, systems, is that new word that we're going to be introduced to in this lesson and lessons going forward. So it says in chapter 3, we graph linear equations in slope-intercept form. In this chapter, we'll be looking at systems of equations, or two or more equations graphed on the same coordinate plane. So if you were having trouble with chapter 3, I suggest you go back and rewatch those videos first, because now we're not going to be doing that once, but we're going to be doing it at least twice on the same set of axes. So in exercise number 1, it says, take a look at the system of linear inequations below. So again, this is a system because there's two equations on the same graph. That's what makes it a system of linear equations. So where do the two lines intersect? So we do agree that we see an intersection point right here. Now, where is that intersection point? That's at the point 2, 2. So they intersect at 2, 2. And now, what are the equations of these linear functions? You may need to use either slope-intercept form, the point-slope formula, or both. So let's go back to remembering that from chapter 3, where we used the slope-intercept form to get the equation of a line that looked like this blue one, for example, where we have a y-intercept of 1 and a slope of 1 over 2. So again, for this blue line, we have y equals mx plus b because we're given the slope and the y-intercept. So we're going to plug in the slope as up 1 over 2. So we have 1/2 x, and our y-intercept is at positive 1. So it's going to be 1/2 x plus 1. On the other hand, for this red equation, we can't use y equals mx plus b because we don't see the y-intercept. So we're going to have to use our point slope formula. Y minus y sub 1 is equal to m times x minus x sub 1, because we are given the slope of this line, because we have this point here and this point here, or that point there, whichever points you want to use. And we also have any point on this line. We're going to use the point 2, 2. So since we're going to use the point 2, 2, we have our x sub 1 value and our y sub 1 value. And we know that our m value is going to be up 3, right 1. So m is going to be 3 over 1, or just 3. So now that we know everything that goes into this formula, we're going to plug it on in. So we have y minus y sub 1 value is 2, is equal to the slope, which is 3, times x minus x sub 1 value is also 2. So we're going to simplify this to get this in mx plus b form, so they look alike. And we're going to get on the right side 3x minus 6, and that's going to be equal to y minus 2. Our final step is going to be to add 2 to both sides to get our final equation of y equals 3x minus 4. So label these functions with their appropriate equations. So now let's go back and let's label that blue line with y equals 1/2 x plus 1. And let's label that red line with y equals 3x minus 4. Okay, now we're ready for part C. And part C says, now that we've found those two equations, substitute the intersection point from part A into each equation. What do you notice? Why do you think that's the case? So we have y equals 1/2 x plus 1, and we have an intersection point of 2, 2, which means it's an x value of 2 and a y value of 2. So let's substitute in 2 for y and 2 for x, and let's see what happens. So 2 is going to equal, half of 2 is 1. 1 plus 1 is 2. So 2 equals 2. That's good. And over here, we found the equation y equals 3x minus 4. And again, let's substitute 2 in for x and y. and we'll get 2 is equal to, well, 3 times 2 is 6, minus 4 is 2, 2 is equal to 2. Both those equations are true. Any other point that you substitute into both of these equations, you'll never get a scenario where it will be true for both of them. That's because the point of intersection is the point at which the first equation is equal to the second equation. So if you take a look at these two lines, think about when they're going to intersect again. And the answer is never. This red line goes off far away from this blue line forever and ever that way, and this blue line goes off forever and ever farther away from the red line that way. So this is the only solitary intersection point, and that is the only set of values that will make not only one, but two of these equations true. So what you just found is one out of an infinite number of possibilities that make these equations true. You have defied the odds, and you are now ready for exercise number 2 in graphing systems of linear equations. If this video was helpful, please give it a thumbs up, and you're ready to move on to exercise number 2 now. Click on the link in the video provided. Thank you for watching.